This lecture is about section 2.4, which is multiplying and dividing integers. Remember, integers are positive and negative counting numbers along with 0. So the basic idea here is when you're multiplying and or dividing integers, minuses cancel in groups of 2. Okay? So when multiplying and or dividing, minuses, so the minus symbol, cancel in groups of 2. Okay, that means whenever you have 2 minuses and you're multiplying or dividing, you just cross them out because they cancel out. Okay, so let's see an example of that. My minus kind of looks wavy there. Let me redo that. It's supposed to be a minus. Okay, so minuses cancel in groups of 2. And example, multiply. Okay, problem number 1. Let's do 3 times negative 4 times negative 5. 3 times negative 4 times negative 5. Okay, so here we actually have 3 numbers multiplied together. But like I said, when you're dealing with the minuses cancel out in groups of 2. So for example, these 2 minuses here for the negative 4 and the negative 5, those actually cancel out because there's 2 minuses, so they cross out. So people like to just cross them out like this. They'll draw a line through them. And that's actually going to give us 3 times positive 4 times positive 5. Okay, and because there's no minuses left over here, we've taken care of all the minuses and we know our answer is going to be positive. But if there were a minus left over, our answer would be negative. Okay, and now we can just do the multiplication without having to worry about minuses and pluses. So doing the multiplication here, we know that 3 times 4 is 12 from our times tables. So we have 12 times 5. And then hopefully also from your times tables, you know that 12 times 5 is 60. So the answer is positive 60. Okay? So remember, when you're multiplying or dividing, minuses cancel in groups of 2. And obviously you can have more minuses or fewer minuses than the number of minuses we had here. So let's go on to problem number 2, example number 2. For this one, we're going to have negative 5 times negative 26 times negative 1. Okay, so negative 5 times negative 26 times negative 1. So we're multiplying here. I know this looks like subtraction out here, but this minus is actually just the same as a minus applied to the 5. It doesn't mean we're subtracting. And like I said, minuses cancel in groups of 2. And it doesn't matter which of these that you cross out, but for example, I could cross out the first 2 minuses, but we're still going to be left with one more minus at the end. And there's nothing for this one to cross out with, so that means our answer is going to be negative. Okay, so now that we know that we have a negative answer, we can go ahead and do the multiplication. Okay, so we have this 1 minus left over, which means our answer is negative. And then we go ahead and do the multiplication. So we can do 26 times 5. We can write it vertically, or you can use a calculator. And 5 times 6 is 30. Carry the 3. 5 times 2 is 10 plus 3 is 13. So we get 130. But don't forget, our answer is actually negative because there was one minus left over that didn't cancel out. So our answer is actually negative 130. Okay? And so that time we had 3 minuses. 2 of them canceled out, but then there was 1 left over. If there's 1 minus left over, you know that your answer is negative. Whereas in problem number 1, we actually had no minuses left over, so our answer was positive. All right. Okay, so I want to do a couple more examples. Example number 3, same instructions, multiply. This one we're going to do 529 times negative 4 times 0 times negative 23. Now something you need to realize is any number times 0 is automatically 0. So if you have a 0 and you're multiplying a bunch of things together, this is automatically going to be 0. So let me write that down. Any number times 0 is 0. Okay, so in particular we have this 0 here. We don't even care about the minuses or the pluses or the numbers. Because 0 is multiplied times these other numbers, our answer is just going to be 0. So everything else cancels out, and we just get 0 as an answer. So be on the lookout for that. If you're just multiplying, you have a bunch of numbers, but you see a 0 somewhere, that's going to get rid of everything, and you're going to get 0 as your answer. Okay? Okay, so the next thing I wanted to talk about is exponents. They're sort of a type of multiplication. So let's go over exponents. So problem number 4, let's do 5 squared, or 5 to the second power. So you need to realize that the actual exponent there refers to how many times you're going to multiply 5 by itself. Okay, so exponent, here the exponent is 2, means multiply 5 times itself, and in this case, because the exponent is 2, we're going to multiply 5 times itself a total of 2 times. Okay? So what's that going to look like here? Well, 5 squared, or 5 to the second power, just means you multiply 5 times itself 2 times. So it's going to be 5 times 5. Or you can write it with parentheses, 5 times 5. But notice there's exactly 2 5s, and that's because the exponent is 2. So this is going to give us 5 times 5, which is 25. All right. But notice the original number we started with here was actually positive, so we didn't have to worry about any minuses when we were doing this multiplication. Okay, so let's see another example of multiplying using exponents. Okay, so problem number 5, example number 5. Let's do the quantity negative 5 quantity squared. The quantity negative 5 quantity squared. So when I say quantity, I mean the parentheses. So here the parentheses around negative 5 mean that the square, or the second exponent, actually refers to the entire negative 5. So if I were to write this out, what this would mean is because there's parentheses around the negative 5, we're going to get negative 5 times negative 5. Okay, negative 5 times negative 5. Again, the exponent of 2 means you multiply whatever the exponent is affecting times itself 2 times. So that's how we got 2 negative 5s. All right, and then these 2 minuses are going to cancel out. Remember, minuses cancel out in groups of 2. So these 2 minuses cancel out and give you a positive 5 for each one. And then we know that 5 times 5 is positive 25. Okay? So our answer for this one is actually also 25. And you might be wondering, well, how did we get the same exact answer when the first one was positive and the second one was negative for the 5? Well, what happens is if you have a square or a fourth power or any even power, and you apply that to a negative number, all the minuses cancel out and your answer ends up being positive. So with the negative 5 quantity squared, those 2 minuses canceled out because there were only 2 of them, and that gave us a positive 25. Okay? Cool. So let's see a couple more examples of this. Okay, so example number 6. Let's try a larger exponent. This time, let's try negative 5 quantity cubed. So again, we have parentheses around the negative 5, so this exponent actually applies to the entire negative 5. But now the exponent is 3, which means we're actually going to multiply negative 5 times itself this many times, so 3 times. So this is going to equal negative 5 times negative 5 times negative 5. So exponent is 3, and that's how many negative 5s we have, 3 negative 5s. So now 2 of these negative 5s are going to cancel out. So for example, I could cross out the first 2. Okay, but there's still a minus left over at the end, so that means our answer is actually going to be negative. And then doing the multiplication, we know that 5 times 5 is 25. So we have 25 times negative 5. Okay? And then this minus just means that our answer is going to be negative. So 25 times negative 5, if you want to write it out, 25 times 5. Well, 5 times 5 is 25. Carry the 2. That's Max walking in front of the camera. He's being troublesome. 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus 2 is 12. So we get 125. But remember, there's a negative here. So our answer is actually going to be negative 125. So I'll go ahead and box that. Okay, cool. So these exponents can be confusing with the minuses, so I'm going to do a lot of examples of them to make sure you understand all the cases. So there's one more case that I wanted to cover, which is a certain way of writing exponents. So this is going to be example number 7. And for example number 7, we're going to have a negative of 5 squared. Okay, so negative of 5 squared. Now this looks very similar to problem number 5. So with problem number 5, we had parentheses negative 5 parentheses squared, and we got positive 25. This one's almost the same thing. Number 7 is almost the same thing. It's just negative 5 squared, but there's no parentheses around the negative 5. But this actually means something different, and we're going to get a different answer. So on number 5, we got positive 25. So what do you guys think we're going to get for this one? Well, because the square only affects the 5, it doesn't affect the negative, we're actually only going to be squaring positive 5. And we're going to keep the minus out front. All right, so what are we going to have here? What this means is this actually means negative of 5 times 5. Why is that? There's no parentheses. Okay, there's no parentheses. So even though they didn't write the parentheses, what they mean is there's secretly parentheses around the positive 5 and the minus is out front. Okay, so those red parentheses I wrote in there aren't actually in the problem, but that's what is meant by the notation. Okay, but once you understand the notation, it's not so bad. There's just a minus out front, and then we do 5 times 5 is 25. But because there's a minus out front, our answer is actually going to be negative 25. Okay, negative 25. Okay, so as you can see, with problem number 5, we got positive 25, and with problem number 7, we got negative 25. And really the only difference between number 5 and number 7 is that in number 5, there was parentheses around the negative, so the negatives canceled because there's 2 of them. Whereas in problem number 7, there weren't any parentheses around the negative, so the square, or the second power, only referred to the positive 5. So it's actually, the minus just stayed out front the whole time, and we got negative 25. Okay. All right, so let's continue, but so far we've just seen multiplication and exponents, but the other thing in this section is actually division. So let's have a new example here where we divide. Okay, so new example, instructions are divide. Problem number 1 is actually going to be 0 divided by negative 27. 0 divided by negative 27. So if your 0 is in the numerator when you're dividing, and you have any other number in the denominator, the answer is going to be 0. Okay, so let me write that down for your notes. 0 divided by any non-zero number, so any number besides 0, any other number, is 0. Okay, so here we don't really care about the negative 27 on the bottom. As long as it's some number besides 0, 0 divided by any other number is 0. So our answer here is just 0. Okay? All right, and then, so that's like the first case that I wanted to talk about. Here we didn't worry about the minus because 0 divided by any number, as long as the other number isn't 0, is 0. Okay. So problem number 2, I wanted to see just another example of division and 0. But for this one, we're going to have negative 13 in the numerator and then 0 in the denominator. So this is almost like the last problem. It's just this time the 0 is in the denominator instead of the numerator. So we're dividing by 0 instead of doing 0 divided by something else. And it turns out that any other number divided by 0 is not a real number. It's actually undefined. Okay, so what we write in this case is undefined. So any other number divided by 0, any other number divided by 0 is undefined. Undefined. And what does undefined mean? Well, it just means it doesn't make sense. So the way I like to explain it is, if you try to divide 0 into 6, that makes sense. You think about it, if you have no pizza, you try to cut it into 6 slices, you still have no pizza. Whereas if you're taking something and dividing it into nothing, that doesn't make any sense. So here, 13 divided by 0 is sort of like saying we have 13 slices of pizza, but then we're going to divide those 13 slices into nothing. So because it doesn't make sense to take something and divide it into nothing, we say that it's undefined. Okay, so 0 divided into something is 0. But if you have something and you divide it into nothing, something divided by 0, that doesn't make sense, so we just write undefined. So our answer for problem number 2 is undefined. Does not make sense, and that's our way of saying that in math. Okay, so whenever you're dividing by 0 or you're doing 0 divided by something else, it's actually probably the easiest two cases when you're dividing, because 0 divided by anything else is 0, and then anything else divided by 0 is always undefined. Okay, so any other number divided by 0 is undefined. All right. Okay, so now I wanted to do some examples of problems where we're dividing, but we're not dividing by 0 and we don't have 0 in the numerator either. Okay, so example number 3. For this one, let's do negative 33 divided by negative 11. Okay, negative 33 divided by negative 11. So remember, back at the beginning of this section, I said that when you're multiplying or dividing, minuses cancel out in groups of 2. Well, how many minuses do you see here? I see a minus on the top and a minus on the bottom. Well, that's 2 minuses, so those 2 minuses actually cancel out. So I can cross those out, those cancel out, and then there's no minuses left over, which means the answer is going to be positive. Okay, so we're just going to be doing 33 divided by 11, and 33 divided by 11 is 3, just using your times tables or a calculator, because we know that 11 times 3 is 33. So our answer is just positive 3. Okay, so multiplying or dividing, if you have 2 minuses, they always cancel out and become plus. Okay. All right, cool. So I wanted to get to a little bit more complicated example, just to do a little bit more challenging division. So most of the division in your homework is pretty straightforward though. It's going to mostly be your times tables. So let's do 144 divided by negative 6. Okay, 144 divided by negative 6. So how many minuses do you see here? I see a plus on the top and a minus on the bottom. So because there's only one minus, it won't cancel out with anything. So that means our answer is going to be negative. Alright, there's only one minus, so it doesn't cancel out. So our answer is going to be negative. So right now we know it's a negative answer. And then for the rest of the problem, we have to do the division. Now you could just do this on a calculator, that would be fine. I'll go ahead and write it out with long division, because it's not actually in your times tables. Okay, so over here I'm going to write long division. We're doing 144 divided by 6. And we know our answer is going to be negative, but the rest of the problem is the same as any other division problem. So how many times does 6 go into 14? Well, it goes twice into 14. So 6 times 2 is 12. And then 14 minus 12 is 2. Okay, but we're not done yet. We still have to bring down the 4. So I bring down the 4, and we get 24 down here. And then how many times does 6 go into 24? Well, from your times tables, you should know that 6 times 4 is 24. And then multiplying, 6 times 4 is 24, we get 24 minus 24 is 0. Okay? And after doing that, since our remainder is 0, that means our answer is just up here. But it's not positive 24, it's going to be negative 24. Because remember, at the beginning of the problem, we said there's a minus there on the bottom. So that's actually going to be negative 24 as our answer. All right.